Okay, ladies and gentlemen, this is Mr. Green, and this is my last topic in geometry for Unit 4. Unit 4. We've been looking at circles. One of the things that we've been talking about in circles is, the length of lines and the length of the measure of angles and things like that. But one of the things we haven't talked about is there an equation for the circle? Well, we're going to look at that today, and it's the last topic we're going to talk about in Unit 4, and then we'll be on to the unit tests. Don't forget, make quiz corrections, due dates. You got to make certain you keep those things in mind as you're going through the course. Okay. This is the equation of a circle. Now, in case you look at this and you go, that looks very familiar to me. I've seen that before. It's actually the Pythagorean theorem. If you look at a triangle, a right triangle right here, well, this is the x direction and this is the y direction, right? And if you look at this real closely, x minus h. Well, x is this point right here minus h. X minus h would be this distance right down here. And y minus k would be this distance right here. And so I'm actually drawing a right triangle there, aren't I? Now, if x and y is any point on this circle, I'm drawing lots of right triangles with this, and it could be any number at all, couldn't it? That is how we developed the equation for a circle. And we know that this distance here is the radius of the circle. And so what we're saying is from the center, hk, we take any point x minus h squared plus the y value, y minus k, the y value for the center, k, squared, will be equal to the radius squared. And it becomes a real easy little equation for us to use. So if I'm looking at a circle that's at the center, or at the origin right here at 0, 0, my h and my k become 0, and so what am I looking at? I'm looking at x squared plus y squared. Radius of 5, 25. X squared plus y squared equals 25. That's an easy way of doing this, and it becomes real simple to look at. Look at this one. I've got a circle here. They asked me to write the equation for it. I can see that the center is at 0, 0. So my h and my k are going to be zeros. So I'm going to have x squared plus y squared is equal to my radius squared. Well, what is my radius in this situation? I can count it out. There's 1, 2, 3. So it's 3 units long. So that's going to be x squared plus y squared is equal to 3 squared, which is 9. There's the equation for that circle right there. It'll give you that circle every single time. Okay? How about this circle here? We're looking at a center that's at negative 3, 1. So I can put that value in for my h and my k. I can say x minus a negative 3 plus y minus a 1 is equal to, well, it's 4. They gave me the radius of 4 there, right? Yeah, 4. So that'd be 4 squared. So minus and a minus, that's a positive. So I would have x plus 3 squared plus y minus 1 quantity squared will be equal to 16. That's how you can write the equation for a circle. And we notice by looking at this, if it's a positive, we know it's a negative center. So the negative 3, 1 would be my center, right? Can we do that? How about writing this equation? We're at 2, negative 3, okay? So what am I going to do? I'm going to say that x minus 2 quantity squared plus y minus a negative 3 quantity squared will be equal to the radius squared. Uh-oh, they didn't give us the radius. They gave me a 0.41 here. So you know what? We can actually figure the distance between these two, can't we? Right? By using the distance formula. And I can say that 4 minus 2, that's 2 squared, plus 1 minus a negative 3, that's 4, that's 16. So 2 squared, that's 4, plus 16 is equal to 20. So the distance here is actually the square root of 20. So when I square that, I'm going to get 20 as my squared number. Square root of 20 squared is 20. And so that's what I would come up with as my equation. X minus 2 squared, y minus a negative or plus 3 squared is equal to 20. Cool? Okay, let's go ahead. What if I gave you an equation? What if I said x plus 4 squared plus y minus 1 quantity squared equals 4. Well, I can know that by seeing this plus here, that's going to be a negative 4 as my center. And seeing a minus there, that means my y value is going to be a 1. So my center is going to be at negative 4, 1, right there. I found the center. Woohoo. My radius squared is 4. So my radius is going to be the square root of 4, or 2. So that means I'd go out here to 2, and I would put a point 2 units away from that point right there. Let's see here, 2 units away from that point right there. And I could actually draw a little circle that goes through those 4 points, just like that. Okay, so Mr. Green can't draw a circle. But that's the way you would find a circle given an equation. Looking at this one, see the plus sign here? Means that's going to be a negative. Negative 4. Minus sign here, that means 2. That's my center. Negative 4, 2. Negative 4, 2. Boom, right there. 9. Perfect square. That means my radius is going to be 3. That means I just have to go out 3. 1, 2, 3. Up 3. 1, 2, 3. To the left 3. 1, 2, 3. 1, 2, 3. Down 3. 1, 2, 3. And connect them with arcs that make it look like a circle. Do you see how I found the center? Do you see how I found the radius? That's what a lot of the equations of a circle are, is finding the center of the circle, finding the radius. Okay? Now, intercepts. Intercepts of a circle are, when we're looking for y-intercepts, that's the point on the y-axis where it hits, right? Well, I want you to notice this. X squared plus y squared equals 25. That means I got a radius of 5 at a center of 0, 0. What are my intercepts? They're at 5 and at negative 5. Why is that? Because when you take the square root of a number like the square root of 25, that's actually equal to plus or minus 5, because it could be a negative 5 that we're doing. That's why we're finding the center down here, or this intercept down here at negative 5. Okay? Now, I was doing that to find the y-intercepts because I said x equal to 0 and y squared was equal to 25. What if I had wanted to find the x-intercepts? That's where y is equal to 0. Well, that would have come back with x squared is equal to 25, and I could have solved that. So what am I doing? For intercepts, x-intercepts, y equals 0. Y-intercepts, x equals 0. That's the way you can find them. You can stick those values in and find the intercepts pretty easily. Okay? So, my radius and chord theorem, going back to that, by the converse of the radius and chord theorem, given 3 points on a circle, the center of the circle is the circumcenter of the triangle formed by the chords, whose endpoints are the 3 points. So given these 3 points right here, if I draw chords between them, like this, drew chords between them. Now, going back to what we learned in the first unit of the first semester, the circumcenter of the triangle. Circumcenter was found by finding the perpendicular bisectors of each one of the different sides, right? So, 1, 2, 3. Perpendicular bisector of this one is going to be this side right, that place right there. Okay? Perpendicular bisector on this one is going to be like that. Perpendicular bisector on this one is going to come out like this. Okay? And my center is going to be probably right there. I was not doing these exact, but we could find those perpendicular bisectors very easily. Okay? So I just sketched it there to show you where it was going to be. So, this one says, find the equation of the circle -3 after a translation of 4 units left and 2 units down. Translation! That was something else we've talked about in Unit 1. We've talked about it many different times. If I'm moving it, all I have to do is move the center. And it's going 4 units left. That's x. So I'm going to go to the left 4 units. That means I would say x minus 7. Why? Because it went 4 more units to the left, squared, plus, and then 2 units down. Well, that means it's going down 2 units. That means y minus another 2 more units down. That'd be plus 7, because it was at a -2. My circle center was at 3, -5. And it went 4 units left, so I added 4 units onto that. That's where I got the 7. I subtracted 2 units from the 5. That's where I got the 7. Okay? Equals 36. Okay? That means my new circle is going to be at 7, 7, down here. There's my center. My radius is 6, so there's 1 point there. There's 1 point there, and the others aren't going to fit on the screen. And so it would go like that. That's what the circle would look like after it's been translated. Okay? Can you see how we're trying to tie some things back to what we did in the first semester? Translations, circumcenters, things like that. That's where we're at. Okay, we're going to translate this one 8 units right and 4 units up. I'm going to find the center first. The center is at -2, 1. How did I get that? Well, there's my -2 right there, and there's my 1 right there. Okay? And I'm going to go right 8 units. That means I'm going to add 8 onto this. And I'm going to go up 2 units. That means I'm going to add 4 onto this. That means I'm going to be at 6, 5. That's where my new center is going to be. So I can write the equation real simply. That'd be x minus 6 quantity squared plus y minus 5 quantity squared will be equal to 9. I can sketch it easily enough. I go to 6, 5, put my center in there, and then I'm going 3 units on each direction. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I'm going to draw my circle, connecting the points together, and I have got my translated circle. Okay? And all I did was I took this from -2, 1. From here, I went right 8 units. So that was my old center right here. So went right 8 units. 1, 2, 3, 4, 5, 6, 7, 8. And I went up 4 units. 1, 2, 3, 4. Can you see that how all I did was move that up and over? Okay? Okay. I do appreciate the fact that you guys do let me know that you're in geometry every time you send me K-mails. It really does help. Teachers do appreciate when you tell us where you're located, okay? Because then we can locate you and answer your questions more specifically quicker, okay? I look forward to talking to you next time.